Alright, so hopefully you guys have a chance to work out these questions, and now let's go over them together. Number 16. As you can see, we are going to work out these factoring questions together. This right here is x to the third power, but this is y to the third power. The rest are the same, right? So what's the difference in the steps? Let's talk about this first. We are going to factor 27x to the sixth power plus 8x to the third power. Well, because this is x, right? X to the third power, and this is x to the sixth power. In fact, we can take out the GCF. For the number 27.8, we cannot do anything with it, but for the x, well, we could, right? So we are going to factor out the one that has a lower exponent. So the first step is we will factor out x to the third power, and then you see original here for the first one, we have 27. Well, we didn't factor out any number, so it's still 27. But this was x to the sixth power. We took out 3 of them. So now this becomes x to the third power. And then this is just plus 8 because we didn't factor out any number. And x to the third power is out already. So this is what we have. That's the very first step. Could we do the same thing right here? No, because this is y to the third power, x to the sixth power. They are not the same. Okay? And let's focus on finishing this first, okay? And this is how we're going to continue. This is still, okay, x to the third power. Let me just write it down. But then for this right here, we have 2 terms, right? And you see, we have x to the third power, so this is a big hint. We are going to use one of the formula. This is sum of 2 cubes. And this is how we get ready. Let's open a big parenthesis right here. And then inside, for this one, I'm going to look at that as something to the third power, and then plus something to the third power for the 8. Well, originally this is 27. What to the third power will give us 27? The answer to that is 3, right? 3 to the third power give us 27. And we also have to have this x in this parentheses. And how about for this one? We need to have the 2, right? So let's put down the 2. And now for this here, we can factor out the sum of 2 cubes. We still have this x to the third power all the way in the front though. And then for this, the first little parenthesis is going to be a plus b, which is 3x plus b, which is the 2. And then for the second parenthesis, is the one that has 3 terms, right? And for the first term right here, we take the a, which is 3x, and we put that in the parentheses, and then be sure we square that. 3 squared is 9. X squared is just x squared. This is the first term. And then, when you have the sum of 2 cubes, this right here is minus. And this term here is a times b. 3x times 2. And 2 and 3 together, when you multiply, you get 6. And you have that x, right? At the end, the third term is plus this square, right? So let me show you. We have to get the 2 and then square that. So we get 4. And this is the most that we can do. This right here is the factoring for this one. Be sure to take out the x to a third power first because they are the same factors right here. They both have the x to a third power. Right, now let's look at this right here instead. Well, we couldn't do the common factor, right? So in this case, we go right ahead and we think about if we can use something to the third power. And the reason that I should know this is third power is because we have the 3 right here. So we should use the third power, right? So something to the third power plus something to the third power, sum of 2 cubes right here. 27, I shall plus 3 right here. 3 to the third power is 27. Well, what to the third power will give us x to the sixth power? The answer to that is x squared. Because x squared to the third power, we multiply the powers, we get the 6, right? Here, 8, right? So I need to put down 2. 2 to the third power is 8. And then this, we need the y to the third power, give us y to the third power. And then for this one here, we are going to end up a plus b, which is 3x squared, plus b, which is 2y. And then for the second parentheses, we need to take the a and square that. So let's put it down here. A in our situation here is the 3x squared, but then we have to square that. This square is from the formula, but this square is because the A here is 3x squared. Let's work this out. 3 squared is 9, x squared, and we square that, we get x to the 4. And then we minus AB. So we do this times that. 3 times 2 is 6. X squared times y, just like this. At the end, we add this, and you square that. So let's work it out here. Put a 2y in a parentheses, and then we square that. 2 squared is 4. Y squared is just the y squared. And then we are done. This right here is for this one. And now let's move to the next question. All right, number 17, as we can see, we have 4 terms, right? Therefore, we shall try this by grouping. And we will group the first 2 together and group the second 2 together like this with underlines, right? No parentheses yet. And now let's focus on this first. What can we factor out from 54 and 9? We know that 9 goes into 54 and it goes into 9 as well, right? So of course we can factor out the 9 then. How about for the m? This is m to the third power, this is m squared, so we can factor out the smaller exponent, which is m to the second power. And then we open a parenthesis for the leftover. Originally, this is 54, but then we factor out a 9. You can think about this as 54 divided by 9, we have 6 left, right? And this was m to the third power, but then we took 2 out. So we have m to the first power. And then we bring down the minus, and then you see that for this, the 9 was out already. Likewise for the m squared, but this right here is technically a minus 1. So be sure you have this 1 right here. And then be sure you write down the negative sign. We have to bring this sign down, right? And let's look at 6 and 1. Can we factor out anything? No, right? And how about for the variables? This is m. It has no m right here. So technically, we cannot factor out anything. But technically, we have to factor out a negative 1. You know the deal. So I'm going to factor out a 1 like this. And with that sign right here, this is technically that negative 1. And then we open a parenthesis. You know, whenever you are trying to do it by grouping, these 2 parentheses should be the same, right? And I will convince you guys they are the same. Look at this. This is negative 6m earlier, but then we factored out a negative 1. So now this is going to be a positive 6m. And this was a plus 1, but then we factored out a negative 1. Therefore, this right here should be a negative 1. And you can do a quick check. If you multiply in negative 1 into 6m, you see negative 1 times 6m is negative 6m. And multiplying this, negative 1 times negative 1 gives you positive 1. So they are the same. And now, you see this and that are the same. Therefore, we can factor it out. You know the deal, isn't it? 6m minus 1. And then we put these 2 together. Open the parentheses. This right here is 9m squared. And then we minus the 1, right? Can we do more from here? This right here was done. But then how about this? We have 9m squared minus 1. Yes, look at this. You see that this is the same as saying 3m squared, right? Because you have 3 to the second power is 9. And then m squared is, of course, m squared. And then the minus 1 is the same as minus 1 inside, and then square that. So, with that being said, let me show you. This right here is 6m minus 1. And then for this right here, it's the difference of 2 squares. The answer for this right here is going to be 3m minus 1 times 3m plus 1. A minus b times a plus b, right? And this is the most that we can do. And this right here is the answer for number 17. Right, number 18, once again, we will work out these 2 factoring questions together. And you see the difference is that we have x to the third power here and the x squared. This right here just x to the second power. This right here has no x at all, right? Both of them have 3 terms. And as usual, let's work out this one first, the one on the left-hand side. So what should we do right here? Do we have any common factor from all these 3 terms that we can factor out first? No, right? Because for the 9, for the last term, we don't have any x at all. And since it has 3 terms, can we proceed with the tic-tac-toe method? We'll try it. So let's go ahead and do the tic-tac-toe like this. And I will show you right here what times 4 will give us x to the 4th power. We know x to the 1st power times x to the 3rd power, that will give you x to the 4th power, right? But the deal is that we will balance the powers up right here for these 2 boxes. I would like to put down x squared and x squared. Okay, so be sure you balance the powers and you will see this is going to work out. How about for the 9? This is the positive 9. Well, I'm going to use negative 9 here and negative 1. And I will convince you that this is the correct choice. Because you see, this is x squared times negative 1. That will give us negative x squared. And then this is negative 9 times x squared. That will give us negative 9x squared. And we are able to combine like terms. Negative x squared minus 9x squared, that's exactly negative 10x squared, aka the things that we're looking for in the middle. So we're able to do this, right? And you see, this is the same as going to be x squared minus 9, and then this is x squared minus 1. Can we do anything more right here? Sure. And this time, I'm just going to write down the answer from here for you guys, okay? This is x squared minus 3 squared. So we can factor this out. This is going to give us x minus 3 times x plus 3 from here, okay? On the other hand, x squared minus 1 squared. This is going to give us x minus 1 times x plus 1. This is it. We have 4 factors right here, right? How about for the second one right here, x to the 4th power minus 10x to the 3rd power plus 9x squared? Is there anything that we can do first before we do the tic-tac-toe? Yes. The thing that we can do first is that we are going to factor out an x squared first because they all have x. And then we factor out the lowest exponent, which is the 2 right here. And then the leftovers are x squared because originally it has 4. We took out 2, right? And for the middle part, we have minus 10. This was x to the 3rd power, but then we took out 2 of them, so we have x. And then for this one, the x squared was out already, so we have a plus 9. And now what? We still have this x squared in the front, but then this, that, we can factor it, right? This is the easy situation. And I'm just going to open 2 parentheses. I know I need to have x and x to give me x squared. And then for the 9, you know the deal. It's negative 1, negative 3. Negative 9, I mean. And this right here is it. X squared times x minus 1 times x minus 9. Okay? So it's quite different. And we cannot go any further right here because this is only x to the 1st power, x to the 1st power, right? Unlike earlier, we could have go one more step. And now let's look at the next one. All right, number 19, once again, we are going to work out 2 factoring equations together. And you can see that here we have y squared, but this is y to the 4th power, right? And let's focus on this right here first. How can we factor out x to the 4th power minus 81 y to the 2nd power? We have 2 terms, but then this is x, this is y. They are not the same, so we cannot factor out any common factor, right? But then you see that the powers, this is 4 and this is 2. They are both even. So I'm going to try to do this by the difference of 2 squares. Okay? So to get ready, I'm going to open a parentheses and then rewrite the first term as something to the 2nd power. And then minus something else to the 2nd power. And hopefully that can give us the 2nd term. How can we fill in the first parentheses right here? Well, to get x to the 4th power, I need to have x squared inside because x squared raised to the 2nd power, we multiply these 2 exponents, 2 times 2 will give us the 4, right? And for the 2nd parentheses, as you can see, we need to get 81, therefore we should have the 9. 9 to the second power gives us the 81, right? And here we just need a y, because y to the second power, yes, y to the second power, right? And now you see, we can work this out as a squared minus b squared, difference of two squares. And this is going to give us a minus b times a plus b. Well, a is this, so we have x squared minus the b, which is that 9y, and then we multiply by pretty much the same thing, but then you change the minus to plus. So we have x squared plus 9y. And now let's take a look at this. Is there anything that we can do? Well, this is x squared minus 9, and we know 9 is 3 squared. However, we have this y right here. Can we write y as something to the second power? Technically, yes, we can use a square root, but we are not going to go there with factorings, okay? This right here is it. And the reason is because for the y, this is not something to the second power, okay? And we are not using square roots or whatsoever. This is the answer. We cannot do anything else. And you will see why I put these two questions together for question number 19. In comparison with this one, well, once again, I will try to do this with the difference of two squares. And for the first parentheses, I'm going to put down x to the second power, raised to the second power, give us x to the fourth power, right? For the second parentheses, I am going to put down a 9 first, but then for this one, I need to end up with y to the fourth power. That means I need to have y squared. Same thing though, a squared minus b squared. So I can factor this as a minus b, which is this, x squared, minus this is 9y squared, okay? And then the other one is going to be x squared plus 9y squared. And take a closer look right here. This is x squared minus 9y squared. What we can do right here is that we can look at this as x squared and then minus something to the second power, right? I can put a string inside. 3 squared will give us a 9. And this time we have y squared, so I can put down a y inside because we can get y squared right here. We couldn't do that earlier. That's why we have to stop right here. And then for the first one, once we look at this as that, once again, it's the a squared minus b squared, the difference of two squared, right? So the factoring for the first one is going to be x minus 3y times x plus 3y. Okay? So this will give us that. And this is the most that we can do. And can we do anything with x to the second power plus 9y to the second power? This is the sum of two squares, right? X squared, and then this is y squared, and then we have the 9. Not factorable. And when it is not factorable, you don't do anything with it, you just bring it down. This is still part of the answer, okay? So make sure you write this down as well. X squared plus 9y squared, and this is it. Okay, and now let's do the last one. Right, number 20, and hopefully after you guys watch all my videos in factorings, and especially we have done 20 examples, right? In fact, we did more because sometimes we do 2 in 1, right? And it just takes practice, and hopefully my videos have been helpful for you guys. If they do, please leave a comment down below and let me know. And if there's anything that you would like to suggest, please do so as well. And this is how we are going to factor out number 20. We have 1, 2, 3 terms, and we see that we have big numbers, and we also have a lot of variables. So it's a good habit to check right here, especially if we can factor out any GCF or not. But then if you look at 8, 11, and 10, we don't really have a number besides 1 that goes into 8, 11, and 10, right? No. How about for the variables? Here we have p squared, here we have p, but then for the third term, we don't have any p. How about for q? Well, q to the fourth, q squared, but then this right here has no q, right? So no GCF. And because we have 3 terms, let's go ahead and do the tic-tac-toe, right? So it's a good choice right here to proceed with the tic-tac-toe. And now, what times 4 give us 8p squared? Well, we have 2 combinations, 8p times p, and the other one is 4p times 2p, right? Let me use 8p and p right here, okay? And now let's look at these 2 boxes. Well, you see, we have q to the 4th power here, and just like one of the previous example that we have done, when we're doing the tic-tac-toe right here like this, we should balance the power, right? To get q to the 4th power, we should have q squared here and q squared here. And now we can focus on what times what will give us negative 10. Well, we know 1 times 10 will give us 10, and one of them should be negative, so we can get negative 10, right? Another choice is 2 times 5, and one of them should be a negative, right? Let me put down 2 and 5, and let me do it like this. 2 right here, and 5 right here, okay? I'm not sure which one to make it negative yet. And if you would, I can proceed to check already. 8p times 2q squared give us positive 16p q squared. And you see the term match in the middle, right? And I'm going to multiply this and that. So we get 5p first, and then q squared. And you see, this is 16 and this is 5. How can we get positive 11? Well, the 5 should be negative, right? And that means I should have this 5 being negative. Because now, if I do negative 5q squared times p, this right here will be the negative 5. Same term like this right here, right? And I will show you when you combine this in the middle. 16 minus 5 is 11, and we keep the same term, pq squared, then which this match with the middle. And now, we know this is going to be, remember, read the answer across. We have the 8p right here, minus 5q squared, and this is how you should write the q in math, otherwise it looks like a 9. Alright, the other factor is p right here, and this is a positive 2, so it's plus 2q squared. And can we factor out more right here? No. So this right here is the answer, and once again, I hope all my examples helped you with your algebra class.
That's it.